Hi everyone. So today we're going to carry on with partial fractions. So we're going to be looking at what to do when we're given a certain rational function so that we can split it up into those individual terms. Okay. So I hope everyone watched the last lecture on what to do if the degree of the numerator is bigger than the degree of the denominator. So if I give you a rational function, before you do any work, you need to check that. Okay, so if the degree of the numerator is greater than the degree of the denominator, you have to do that polynomial long division first. Okay, so please just keep that in mind. This is going to be the second step after you check that. Okay, so we're going to go through the rules by looking at some examples and then seeing what you have to do. So for the first example, we have something like x squared plus 2x minus 1. So a polynomial at the top, and then we have a polynomial at the bottom, but I'm going to factorize that polynomial. Okay, so in the factored form, let's say it looks like this: x times 2x minus 1 times x plus 2. Okay, so we need to factorize the denominator. Okay, so once you factorize the denominator, then there are three cases that we're going to deal with. The first case that we're going to go through is if it's a product of linear terms. So we've got x, that's our first term, 2x minus 1, that's the second term, x plus 2, that's the third term. We see they're all linear with respect to x. So if this is the case, then we can split this up into some constant a over x for our first term, plus b over 2x minus 1 for the second term, plus c over x plus 2 for the third term. Okay. And if we had more terms, then we just add more of these fractions here. Okay, and then these constants a, b, and c, there's two methods we can use to figure those out, but I'm going to save that for the example later on. Okay, so just to go over this again, given a rational function, you check that the degree of the numerator is less than the degree of the denominator. If it's not, you have to do polynomial long division, which we covered last time. Okay, once that's done, you factorize the denominator. So here we factored it into 3 terms being multiplied. Then we split up the fraction like this. So we have a over the first term, plus b over the second term, plus c over the third term, and then we'll figure out what those constants are later on. Okay, but this is the method if we have a product of linear factors. Okay, so that's case 1. Case 2 is if we have a product of linear factors, but some are repeated. So let's do an example of that. So let's say we have x cubed minus x plus 1 over, and then let's say we factorize the denominator and we get the following: x squared x minus 1 cubed. So we see here that this x term is repeated twice because it's x squared, so it's like x times x. And we see that the second term, x minus 1 cubed, is repeated 3 times, because we could write this as x minus 1 times x minus 1 times x minus 1. So it's repeated 3 times. So just to illustrate that, let's write it out. X cubed minus x plus 1 over x times x minus 1 times x minus 1 times x minus 1. So you see that this first one is repeated 2 times, and the second one is repeated 3 times. Okay, we can see that in the exponents. Now, if that's the case, then we need to write one of these fraction terms for each power of the term. So let's just show that. So the first one is x repeated twice. So we're going to have a1 over x, and then we need another term, a2 over x squared. So we have a term for each power going up to however many times it's repeated. So here it's repeated twice. So we have a1 over x plus a2 over x squared. Now the second term is repeated 3 times. So we're going to have to do it 3 times. So we're going to have plus b1 over x minus 1. So that's the first one. Plus b2 over x minus 1 squared. That's the second one. And it's repeated 3 times, so we do it one more time. b3 over x minus 1 cubed. Okay, so we have x squared, so we write it up to power 2, because it's repeated twice. And we have x minus 1 cubed, so we have it up to the power 3. Okay, so we write all the terms up to the power of however many times it's repeated. Okay, so we could have written this as x1, and we could have written this as x minus 1 to the power 1. Okay, so there's a term for each power going up to however many times it's repeated. Okay, and then you just do that for all of the repetitions that you might have. Okay, so that's case 2, if we have repeated terms. And the last thing that you need to worry about is case 3. That is, what happens if there are nonlinear terms? For example, there could be quadratic terms or cubic terms. So let's look at an example of that. So we have x over x minus 2, that's a linear term. X squared plus 1, that's a quadratic term. X squared plus 4, that's another quadratic term. And x cubed plus 2, that's a cubic term. So you see we have a mix of a linear term and some nonlinear terms. Okay, so what do we do in this case? Okay, we do a similar thing as before. We're going to split it up on each term. So the first one, the x minus 2, we're going to have a over x minus 2. Now for the second term, it's not going to be b over x squared plus 1. It's going to be a polynomial that's 1 degree less. So if the bottom term here is quadratic, then the top needs to be linear. So it won't just be b, it's going to be bx plus c over x squared plus 1. So you see if the bottom part is quadratic, so x squared plus 1, then at the top we write a general linear term. Yeah, it's 1 degree less than what we had at the bottom. Okay, so let's see if we can do the next one. Okay, so the next term is x squared plus 4. It's quadratic, which means the top part needs to be linear. So we write dx plus e, because that's a general linear term, over x squared plus 4. Okay, again, that's another general linear term. Now for the next term, it's x cubed plus 2. That's cubic, which means the top has to be 1 degree less. So it's going to be a general quadratic term. So it would be fx squared plus gx. Sorry, that's an x up there. Plus h. So you see it's a general polynomial of degree 2, which is 1 less than what the denominator is, which is x cubed plus 2. So here we have a general quadratic term over there. Oops. Okay, so that's what we do if the degree of the numerator is higher than 1. So in either of these cases here, we've got x squared plus 1 for the first nonlinear part. So that means the numerator needs to be linear. The next one was x squared plus 4, that's quadratic, which means the numerator must be linear. And then the last one is x cubed plus 2, that's cubic. So the numerator must then be quadratic. It's always 1 degree less. Okay, good. I see everyone's putting their student numbers. That's good. If you haven't put your student number yet, please do so. Okay, so these are the 3 cases that we need to deal with. Okay, let's take a look at an example. Okay, so like I said in the last lecture, we're doing this whole partial fraction decomposition in order to make certain integrals easier to do. Okay, those rational integrals. Okay, so let's do an example of that. Okay, so let's say we want to integrate 2x squared minus x plus 4 all over x cubed plus 4x. Okay, we want to try and integrate this. So step 1, make sure that the degree of the numerator is less than the degree of the denominator. So the degree of the numerator is 2. The degree of the denominator is 3. So that's fine. If the degree of the numerator was more than the degree of the denominator, you would have to do polynomial long division first. Okay, but we don't need to do that in this case. Second, we need to look at the denominator and factorize. Okay, so let's do that. So this is going to be 2x squared minus x plus 4 over, we need to factorize the denominator. So that's going to be x times x squared plus 4. So notice the first term is linear, the second one is quadratic. Okay, so this is a case 3 situation. Okay, so how do we separate this out? The first term is linear, so it's just going to be a over x. The second term in the denominator is quadratic, so it's going to be bx plus c over x squared plus 4. Okay, so we have separated it out into 2 parts. What we need to do now is figure out what is A, what is B, and what is C. Okay, so we don't know what these are yet. Okay, so how do we go about figuring that out? Okay, so we know 2x squared minus x plus 4 over x times x squared plus 4 is equal to a over x plus bx plus c over x squared plus 4. Okay, so what I'm going to do now is multiply both sides by x times x squared plus 4. So times by x times x squared plus 4. So if we look at the left-hand side, if we multiply by that, the denominator is going to cancel. So we're going to get 2x squared minus x plus 4. If we look at the a term, the x is going to cancel. So we're going to have a x squared plus 4 plus, and then in the b and c term, the x squared plus 4 is going to cancel, and we're left with x times bx plus c. Okay, so now there's a number of ways of solving for a, b, and c. Okay, so the first way is by inspection. So what we can do is substitute different values of x and then use that to solve for A, B, and C. Or we can take the right-hand side and multiply it out, and then compare coefficients. So let's take a look at that method first. So we're going to have 2x squared minus x plus 4 is equal to ax squared plus 4a plus bx squared plus cx. Okay, so I've just multiplied everything out. Now I can collect my like terms. Okay, so 2x squared minus x plus 4. The x squared terms I can collect. So I'm going to have a plus b x squared plus cx plus 4a. Now I'm going to compare the coefficients on either side. So the first one is 2 goes with x squared, and AB goes with x squared. The next, minus 1, there's a minus 1 there, goes with C. And 4 goes with 4A. Now, if these two polynomials are to be equal, then their coefficients must be equal. Therefore, A plus B must be equal to 2. C must be equal to minus 1. And 4A must be equal to 4. Okay, but if 4A is equal to 4, that means A is equal to 1. And if A is equal to 1, then B is also equal to 1. So altogether, we have that A is 1, B is 1, and C is minus 1. So we found our coefficients. Okay. So you can use that method to find the coefficients. So you expand everything out on the right-hand side, and you can then compare the coefficients. There's another method that you can use. So let's say we had 2x squared minus x plus 4 is equal to a x squared plus 4 plus x bx plus c. What we could do is choose different values of x to substitute in our equation. Since we have 3 unknown variables, we need to choose 3 values of x, okay, to give us 3 equations. So if we let x be equal to 0, then we're going to get the equation 4 is equal to 4a. Okay, if we just substitute x equals 0. If we let x be equal to 1, then we're going to get 5 is equal to 5 plus b plus c. Okay, because we already know what the value of a is. So this gives us a equals 1. Okay, and if we let x equal minus 1, then we're going to get 7 is equal to 5 plus b minus c. Okay, and then we can use equations 2 and 3 over here to solve for b being equal to 1 and c being equal to minus 1. Okay, so you can use either method. You can either expand everything out and compare coefficients, or you can choose different values of x and then solve simultaneously. Okay, either way, you're going to be solving simultaneously, but sometimes it's easier to use one method over the other. Okay, so I'm going to leave that to you to pick which one you like, but I would stick to one method. Okay, so sometimes one method is easier over the other, but it gets confusing, you know, going between 2 different methods. So I would try both methods on the homework, and then just pick one. Okay, so whichever one you feel most comfortable with, pick that one and then stick with that. Okay, but if you are comfortable going between the 2 methods, then that's perfectly fine as well. Okay, either case, we get the same answers here. Okay, so let's carry on. So we have the integral of 2x squared minus x plus 4 over x times x squared plus 4 dx is equal to, and we expanded it out over here, it's a over x plus bx plus c over x squared plus 4. So let's just substitute what we know. A is 1, so it's going to be 1 over x plus x minus 1 over x squared plus 4. Okay, so we want to figure this part out now. Okay, so what do we do? Well, we can separate the second term out because we know what to do if it's in two parts there. So this is 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4. Okay, that's looking a lot nicer than what it was before. So this term, we know what to do. This is just a u substitution problem. So let's put u sub. Okay, you let u be equal to x squared plus 4. du is then going to be 2x. Okay, so half du is x, which is what we have at the top. Okay, so that's just a very simple u sub problem. This term over here, that should look familiar to you. That's the one with arctan. Okay, the 1 over x squared plus a squared. Okay, that's an arctan integral. So just put tan inverse there. And then this first one, we've seen this lots of times now. That's just going to be the natural log of x. Okay, so each part is pretty easy to do on its own. So we just put everything together. The integral of 1 over x, that's going to be the natural log of x. The integral of the blue one, you just do your u substitution. You can check that. We get 1/2 the natural log of x squared plus 4. And then the last one here, we need to do the arctan, okay, because it's like 1 over x squared plus a squared. That's going to be minus 1/2 tan inverse of x over 2. Okay, I'll let you check that one out as well. Plus c. Okay, so once you've done your partial fractions and you've separated it out, you just need to integrate each of the terms and then add it all together. Okay, now just a little warning here. When you do find these coefficients, substitute the coefficients back just to check that they work. Okay, so you might make a small little addition mistake, somewhere here, maybe you put a plus instead of a minus or something like that. So please check your coefficients, because if you substitute the wrong coefficients into your integral, then everything is wrong after that. Okay, so it's very important to check them before you move on. Okay, so please check your coefficients. Okay, so it will be terrible getting all your coefficients, doing all your integration, and then, there's a plus instead of a minus, and then you can't do the integral or something like that. Okay, so always check before you carry on with the integration. Okay, are there any questions so far? Okay, let me just check the chat. Okay, no questions there. Okay, so that's the basic idea of partial fractions. So let's just go through the steps one more time. So you're given a rational function. The first thing you need to do is check, do I need to do polynomial long division? If you do have to do that, you do your working on the, you do your working on your side, and then you'll get something where the degree of the numerator is less than the degree of the denominator. Okay, once you get to that step, you can use your partial fractions. Okay, so step 2, you look at the denominator and you factorize. So here we had x cubed plus 4x. You factorize that fully into x times x squared plus 4. Okay, step 3, you use your partial fractions to separate it out. So here we had 2 terms in the denominator, so we have 2 terms in the decomposition. Okay, once you've done that, you find your coefficients. Either you multiply everything out and compare coefficients, or you can choose different values of x to get your equations. If there are 3 unknowns, then you need 3 equations. Okay, so we use 3 values of x. Okay, you get your coefficients. Please check your coefficients so you don't make any sign mistakes. Okay, then you substitute your coefficients back into your decomposition formula. You will get a number of terms at the end. Okay, so we got 3 terms here. You integrate each of the terms and then add it all together. And don't forget your plus c. Okay, so that's all the steps involved in this partial fraction decomposition and integration. Okay, so any questions before we move on? Okay. So we're just going to go through some of the helpful formulae that you should know when doing these. So firstly, for all of those linear terms that you need to integrate, it's good to know that the integral of 1 over x plus a is equal to the natural log of x plus a, okay, plus c. Okay, so of course we've done this plenty of times before, but I just want to write all of them out so you can use it for reference. Okay, so number 2, if you're dealing with the quadratic terms, these are important to know. So we have the integral of 1 over x squared minus a squared. Okay, if you have something like that where it's quadratic in the bottom, this is going to be 1 over 2a, the natural log of x minus a over x plus a, plus c. Okay, the proof for this I'm going to leave as a homework problem. Okay, so just a little bit of partial fractions and then you can show this. Okay, number 3. The integral of 1 over x squared plus a squared dx. Okay, so if you have something like this, it's going to be 1 over a arctan of x over a plus c. Okay, I'm going to leave this for homework as well. You can show this. So remember, all of these homework questions count towards bonus marks for your assessments and tests. So it's good to try it out. And okay, so those are some integrals that are quite useful. So please remember these and then try number 2 and 3 for homework. You can get some bonus marks for that. Okay, and then we've got 2 homework exercises. Okay, so the homework exercises, they're not these proofs, so it's problems to solve. The first one is the integral of x minus 4 all over x squared minus 5x plus 6 dx. Number 2, x squared plus 2x minus 1 over x squared plus 3x plus 2. Okay, try that one out. And number 3, the integral of the square root of x plus 4 over x. Okay, we're going to do more of that next time. Okay, but give it a go. I'll give you a hint here. Let u be equal to the square root of x plus 4. Okay, so after you do the u substitution, you should be left with a partial fractions problem. Okay, but we'll look at more of those next time. Okay, so we've got 3 integrals that you should remember. Okay, and then proving 2 of those I will leave for homework. And then some problems to try as well over the weekend. Okay, now, okay, so that's it for today. Remember, next week, Monday is a public holiday, so we won't be having a live lecture. Instead, I will upload a video going through some more examples, so you can have a look at that. And then Tuesday, we will carry on with more examples, more like this last one here. Okay, we'll look at those examples. Then on Wednesday, you've got your formative quiz on trig substitution. And then after that, we will start the new section. Okay, so not much left for the semester. Okay, any questions on what we've done today? Okay, so try out these homework problems. If you have any questions, please ask on the WhatsApp group. And later this evening, I will upload the solutions for all of this homework stuff. Okay, and then you can have a look. And remember, next week, Wednesday, is the tutorial again. So we missed last week's tutorial and this week's tutorial. So remember, tutorials are still happening. So you have this weekend to go over those problems on partial fractions. Okay, then you'll have your tutorial on Wednesday. Okay, I'll see everyone on Tuesday. Bye, everyone.